In this video, we're going to be talking about conversions of pressure units. So in the last video, we talked about the different units of pressure that can be atmospheres, kilopascals, or millimeters of mercury, sometimes called torr. Okay? Now, when we start using the gas laws, we're going to use different units of pressure. And I'm going to use an example here with you real quick. If you were to have to check the pressure on your tire, that pressure gauge has numbers on one side, and then on the other side it has different numbers. So when you go to take the pressure of your tire, you can look at if it's supposed to have 35 pounds of pressure, 35 psi, put it on there and it shoots 35, but many of them, if you flip it over, it has a different unit, and it happens to be in kilopascals, which is used in Europe a lot. But one of the biggest things that you have to be able to do is know how to convert between the units. Okay, this is a very simple skill, and I'm going to show you exactly how to do it. First thing you need to know is that this equals this equals this. Very important. Okay, and I showed you that to you in the last video. Let's do a couple of these real quick. Let's say that we had 2.1 atmospheres, and we need that to be converted to torr. Very simply, we set up what we know into a railroad track like we've done before. So if I'm doing a railroad track, ATM needs to be here, so that word goes away, and I want to be in torr. So ATMs convert to torr. Now, here's how simple it is. This is always the number you're going to use, always the number you're going to use, always the number you're going to use. So 1 atmosphere, there it is, equals 760 torr, or the word millimeters of mercury. So all you do is you grab your handy dandy box, your calculator, 2.1 times 760, if I can get my calculator to work, equals 2.1 times 760, 1,596 torr. And that would be the answer. So what happens if you had a different one? What if you wanted to go from 200 kilopascals and you want to go to atmospheres? Okay. Well, works same way. 200 kilopascals. Kilopascals goes here, so that word goes away. What number's in front of kilopascals? 101.3. And atmospheres is a 1 every single time. So you're going to always use that number or that number or that number. And so it's just a division problem. So 200 divided by 101.3 equals 1.97 atmospheres. So it's literally that simple as you go along. Okay? Let me erase real quick and try one more. Let's say that we wanted to have a different unit. Okay? So let's say that we had 900 millimeters of mercury and we needed it to be in kPa. Again, it's the exact same math. 900 millimeters of mercury, railroad track. Millimeters of mercury, kilopascals. So since they're all equal to each other, you can convert one to another very simply. 760 millimeters of mercury, that unit's gone. That's where I got the number. Kilopascals, 101.3 kilopascals. And so I multiply then divide, or divide then multiply, because it's order of operations, it works the same. 900 times 101.3 divided by 760 equals 119.96 kPa. All right. So any of the conversions, you may be thinking, why would I have to convert units? When we start working problems, when we start learning the gas laws, there are going to be some problems that they're going to work in atmospheres, and then the other unit is accidentally in this unit. So you got to make a match. And so this is how you do it. Now, while we're doing conversions, let's go ahead and do the other conversion. Let's go ahead and do conversions with temperature. Now remember, in the last video we talked about degrees Celsius and Kelvin. Alright? Make sure you look at your notes real quick. Degrees Celsius versus Kelvin. Remember, we said that there's no such thing as cold. There's heat and lack of heat. We will never use degrees Fahrenheit. Degrees Celsius, okay, we know that 0 is the freezing of water, 100 is the boiling of water. You can have negative Celsius, you can go below 0, and you can go above 100. But with Kelvin, it's very different. Kelvin was the bottom of the scale. Remember, there's this magic number, negative 273.15 degrees Celsius is the coldest temperature in the universe. That equals 0 Kelvin. Now, I didn't say this in the last video, but check this, and it looks like okay, and I know that. There are degree signs in Celsius, but there are no degrees in Kelvin. So you'll see numbers that look like this, 57 Kelvin. Okay? It may be a really big number. When they start looking at planets, they may say, okay, it's 1,500 Kelvin on a certain planet or a certain star out in space. And so it's going to be in Kelvin. There's no degree mark when you do that. Now, look, if you'll glance back at your notes, you'll find there's an easy conversion, degrees Celsius plus 273.15 equals Kelvin. That's the magic equation we're going to use. And so one of the things you have to realize is if I'm doing this, then Kelvin numbers are always bigger than Celsius. So if I had 25 degrees Celsius and I need it in Kelvin, I take 25 plus 273.15, got to keep the decimal, and you have your answer. So in this case, it is 298.15 Kelvin. All right? So why would you have to do this? Well, if you have 25 degrees Celsius, that's what's on your thermometer. This is the conversion to have Kelvin. Now, quick reminder, why would we have to even have Kelvin? Because sometimes we have negative degrees Celsius, and when you have negative Celsius and you start to do a calculation with it, you'll get things that are like negative mass. Okay? Like, for example, a rock, and you go to do some mathematics with it, and you find out that it has negative 10 grams. Well, that negative, you can't have negative mass. So you had to have a scale that's always positive. That's why they call it absolute zero. It is going to be an absolute scale. It's always positive numbers. Now, the reverse is also true. If you have a Kelvin number, so let's say you have 85 Kelvin and you need that in Celsius, what do you think you do? 85 Kelvin minus 273.15. Okay, now notice, this is going to be a negative answer. So the question you have to get straight in your brain is, can I have negative Celsius? The answer is yes. So watch. 85 minus 273.15 equals negative 188.15 Kelvin. Oops, excuse me, not Kelvin. Degrees Celsius. So you can have, that's really, 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 really cold. Is that to absolute zero? Well, think about this. If the coldest temperature in the universe is negative 273.15, that's getting down there, isn't it? But it's not to absolute zero. So there are times where you're going to use Celsius, and there are going to be times where you have to use Kelvin. And so we're going to learn those as we go along the way. So in this video, here's what we've learned. We learned how to convert units of pressure and convert units of temperature. All right? So instead of making a whole nother video, I'm going to give you this real quick. Okay? Now you try. Now it's time for you to try. You're going to do a couple of examples here. You're going to have 3.4 atmospheres, and I want to know what that is in kPa. Number 2, I'm going to have 987.3 torr, and I want to know that in atmospheres. And then I have 210 kPa, and I want to know that in torr. Okay, there's those 3. And then question 4, I've got 108 degrees Celsius. I need that in Kelvin. And in the second one, I've got 784.63 Kelvin, and I need that in degrees Celsius. 5 examples. Pause the video, do all 5, and we'll come back and check them. All right, so let's work these problems real quick. 3.4 atmospheres, railroad track. Word atmospheres goes here. 1 atmosphere, kPa. Number is 101.3. Did you put your numbers in the right place? 3.4 times 101.3 equals 344.42. What units? kPa. Make sure you keep up with your units. That's the answer to question 1. Okay. Question 2. 987. That's not very good. 987.3 torr to atmospheres. 760 torr Whoops, marked out the wrong one, didn't I? 760, the word torr's gone, is 1 atmosphere. Okay? So it's a simple division. 987.3 divided by 760. The answer is 1.299 or 1.3. 1.3 atmospheres. Okay? Question number 3. 210 kPa to torr. kPa goes there. Torr goes there. So 760. I know that number. 101.3. So I'm going to multiply, then divide. So take my calculator. 210 times 760 divided by 101.3 is 1.58. 1.58 torr. Okay? Now, I'm sorry, that's a comma on my screen. Ooh, my bad. Different calculator than I normally use. 1,575.52 torr. Okay? I had to look at that again. Okay, so I'll show it to you on the screen again. You can see the decimals out here. Okay, just looked at it wrong. All right. Question number 4 was 108 degrees Celsius to Kelvin. Kelvin numbers are always bigger, so 273.15 is just an addition. Okay, just an addition question. So 108 plus 273.15 equals 381.15. 381.15 Kelvin. Remember, there's no degree sign. And last but not least, 784.63 minus 273.15. 784.63 minus 273.15 equals 511.48. 511.48. What units? Well, this was Kelvin minus this means degrees Celsius. Okay? So those are your answers. If you can do those conversions, you're going to do an awesome job in the gas laws. Coming up, you're going to learn each gas law individually, one at a time. Boyle's law, Charles' law, Glusak's law, combined gas law, ideal gas law, and we'll learn them one at a time as we go, and we'll be using units of pressure and volume and temperature. All right, you're going to do awesome at this.